I'm here today to show you the circuitry for the ArborBot digger, which is a part of a robotic swarm that help in reforestation efforts. The digger will dig a hole using its triangle hoe so that the planter can plant the seeds. I have two gear motors here that will control movement of forward, back, left, and right of the tracked wheels. I have two servos here that will do the up, down, left, and right for the robotic arm that has the triangle hoe attached. This is the IR sensor that everything is going to, and the input and output will go to this remote control that will allow everything to go. And here's our 9-volt battery. So we'll take a look at this coding. So right here we're just establishing pins and integers, servos, servo names. Right here is where we are mapping our buttons on the remote. Right here is our receiver values, which is how the IR sensor takes in information to send it to the remote. Right here is our setup, where it begins. We have all of our output pins except for the receiver pin, which is input. And then this is us establishing what each motor pin does and doesn't do. And then down here is our loop, which is the main thing. Right here's where we have our buttons, our movement. So I'm going to start simulation here. First we have case 6. Case 6 is the right arrow. It allows the bottom motor on your screen to go forward while the left motor does not. And as you see in the serial monitor, it is also letting us know it's turning right. So for case 4, which is the left arrow, it moves the top motor forward while the bottom motor does not move. And as you can see, it says turn left. Then we've got case 1, which is the volume add button. And the volume add button will allow both motors to go forward or to both go. And we've got case 9, which is the volume subtract button. And it will allow both motors to go backwards. As you see, it says both back in the serial monitor. So that is our motors. And then right now is where we start our servo. So servo 1 or Bucky 1 is this one. It controls the arms up and down. So is what we'll do. So case 10, which is the up arrow, moves Bucky 1 up in increments of 5 degrees. Same thing with the down arrow, which is case 8, moves it down. So then we have Bucky 2 or servo 2, which is case 12, which is the 0 key. The 0 key will move it in increments to the left. And then the stop repeat key, which is case 14, will move it to the right. And that is all of our buttons. This is case 0, which powers down. Everything goes to its default, and the motors are stopped. Thank you very much.